Well, now we'll move on to differential manometer. It's a device used to find the difference of pressure between two pipes, 2 points in the same pipe, or two different pipes at the same level or different levels. Once again, I can tell you, differential manometers are used to find the pressure difference between 2 points in the same pipe or two different pipes at the same level or different levels. The pressure may vary from point to point or from pipe to pipe. Okay. Here also you can see a U-tube is there containing a heavy liquid as manometer liquid. The two ends of the U-tube are connected to 2 points, which are here you can see that two different pipes. See, U-tube differential manometers are classified into two, that is U-tube differential manometer, inverted U-tube differential manometer. First we will discuss U-tube differential manometer. You can see the diagram here. It is a U-tube differential manometer. It is connected to two pipes at two different levels. It is marked as pipe A and pipe B. You can see that the atom line is marked as the bottom level of separation between the liquid in the pipe and the manometer liquid. You can see the height of liquid column in the left limb of the differential manometer is H1, and in the right limb the height of liquid column in the pipe is H2, and the height of manometer liquid in the right limb is the pipe of liquid in the pipe is marked as S3, and the height of manometer liquid in the right limb is H2. Once again I tell you, the height of liquid column in the right limb of the manometer, which is a lighter liquid coming from the pipe B, is S3, and the height of manometer liquid in the right limb is taken as H2. So all these heights are taken from the datum line, which is the bottom line of separation between the liquid in the pipe and the manometer liquid, that is known as XS. Okay. Remember the diagram. Now we'll move on to the derivation. First, as you saw in the diagram, H1 is the height of liquid on the left above the datum line XS. It is measured in meters. H2 is the difference in levels of heavy liquid in the left and right limb, or it is the height of manometer liquid from the datum line XS. It is also measured in meters. S3 is the height of liquid in the right limb above the heavy liquid, that is height of liquid column which is above the manometer liquid in the right limb, that is S3. Okay. Rho 1 is the density of liquid in pipe A. Rho 2 is the density of heavy liquid, that is mercury. Then all these densities are measured in kilogram per cubic meter. Rho 3 is the density of liquid in the pipe B. Okay. Now XSB is the datum line that we have described or discussed when we studied the U-tube manometer. Differential manometer also same case. X be the datum line, and pressure at A and B are, we can give it as PA and PB. PA and PB. Okay. Two pipes, two pressures, PA and PB. Okay, respectively. Newtons per square meter, it is a measure. It is a unit, that is we can call it as Pascal also. Now pressure above XX in the left limb is equal to PA plus rho 1 GH1. That means PA is the pressure of liquid in the pipe A plus height of liquid in the left limb is H1. That means the pressure will be rho 1 GH1. Rho 1 is the density of liquid in the pipe A. Okay, PA plus rho 1 GH1. Similarly, pressure above the XX in the right limb, that is equal to PB plus, PB is the pressure of liquid in the pipe B, plus density of liquid in the pipe B is rho 3, that is its height is S3, so the pressure will be rho 3 GH3 of the liquid, or the pressure exerted by liquid in the right limb, that is the rho 3 GH3, plus the pressure of the manometer liquid, that is rho 2 GH2. So we will check the diagram once again. See, I can tell you PA is the pressure of liquid in the pipe A plus rho 1 GH1. Rho 1 is the density of liquid in the pipe, and H1 is the height of liquid column in the left limb above XS. Now you see that is equal to liquid column balancing, it is equal to the pressure in the right side of the manometer. Okay, that is the pressure of the liquid in the pipe B is PB plus, first you will check the pressure of the liquid that is coming out from B is rho 3 GH3, that is in the right limb because S3 is the height, rho 3 is the density, then rho 3 GH3 plus manometer liquid, pressure exerted by the manometer liquid is equal to height is H2 above XX, so rho 2 GH2, rho 2 is the density of the heavy liquid. Okay, so PA plus rho 1 GH1 is equal to PB plus rho 3 GH3 plus rho 2 GH2. Okay. So we can see that PA plus rho 1 GH1 is equal to PB plus rho 3 GH3 plus rho 2 GH2. Assuming pressure at A is more than pressure at B. Simply we can assume that pressure at A is more than pressure at B because we can, from the diagram also we can see that the level of mercury in the left limb is lower than the level of mercury in the right limb. That means more pressure is at A. The pipe, more is pressure is from pipe A. Okay, from the liquid from pipe A. So assuming pressure at A is more than pressure at B, so PA greater than PB. So difference in pressure for both pipes or points. If it is same pipe, we can say points. Other different pipes, we can say pipes. Okay, PA minus PB. So PB has, we have brought the PB to the left side and rho 1 GH1 to the right side. So PA minus PB is equal to rho 3 GH3 plus rho 2 GH2 minus rho 1 GH1. If both pipe carry the same leak, another condition is another condition. That one, first one is general condition. Two pipes, two levels, two different liquids. Here, if we have the same liquid in both the pipes, then actually density will be equal. Okay, that is rho 1 is equal to rho 3. So we can give it as rho. Rho 1 is equal to rho 3 is equal to rho. Substituting this in the above equation, then PA minus PB is equal to rho GH3 because we substituted rho 1 and rho 3 as rho. So rho GH3 plus rho 2 GH2 minus rho GH1. So we can give it as rho 2 GH2 plus rho G into H3 minus H3 minus H1. This is an equation for finding out the pressure difference between two pipes having same liquid and the pipes are at different levels. Now we will move on to differential manometer connecting two pipes or points at the same level. Okay, first one was pipes at different levels. Now the pipes at same level. Okay, now you see the diagram. The pipes are at same level. Two pipes, the center of two pipes are at the same level. You can see the height of liquid column from the datum. Datum is taken as the bottom level of separation between the liquid in the pipe and the manometer. So left side it is bottom level. So axis is taken. You can see the height H1, that is height of liquid column, the left limb of the manometer. Now S3 is the S3 is the height of liquid column, the right limb of the manometer. That is the height of liquid coming out from pipe B. And now S2 is the height of manometer liquid from the datum XX. So we can see that since both A and pipe B are at the same line, you can see that H1 is equal to H2 plus H3. Okay, H1 is equal to H2 plus H3. That is bear in mind when we go for derivation. Okay, bear in mind that H1 is equal to H2 plus 3. Once again, I can explain. A liquid flowing through pipe A is connected to a differential manometer at the left limb, and another liquid passing through pipe B is connected to the right limb of the manometer. And the height of liquid column, the left limb of the manometer is H1, and height of liquid coming out from pipe B, the right limb of the manometer is H3, and the manometer liquid which is heavier, that is usually we select or we choose mercury. A height of mercury in the right limb is H2. Now we will see the derivation. Okay, first H1 is equal to H2 plus H3, that is shown in the diagram. Now pressure in the left limb is equal to pressure of liquid in the pipe A is equal to PA plus rho 1 G into H2 plus H3. Rho 1 G into H2 plus H3. Okay. Now that is why H2 plus H3, because H1 is equal to H2 plus H3. Okay. Pressure above excess in the right limb. Now we will check what is in the right limb. PB is the pressure of liquid in the pipe B plus rho 2 GH2. Rho 2 GH2 is the pressure exerted by the manometer liquid plus rho 3 GH3, that is the pressure of liquid in the pipe B, the right limb of the manometer. Okay, equating the pressure in the left and right limb above datum limb. Above the datum we have to equate it, that is liquid column balancing. PA plus rho 1 G into H2 plus H3 is equal to PB plus rho 2 GH2 plus rho 3 GH3. Assuming pressure at A is more than pressure at B, that is PA greater than PB. We are assuming pressure at A is greater than pressure at B, because from the diagram we can see that the level of mercury in the left limb is lower than the level of mercury in the right limb. Okay. Difference in pressure for both pipes or points. PA minus PB. Okay, PB has, we have brought the PB from right side left side of the equal sign. Okay, then PA minus PB is equal to rho 3 G3 plus rho 2 G2 minus rho 1 G into H2 plus H3. So rho 3 G3 plus rho 2 G2 minus rho 1 GH2 minus rho 1 G3. If the two pipes contain the same liquid, then naturally rho 1 is equal to rho 3 is equal to rho, we can give it as substituting this in the above equation. PA minus PB is equal to rho 2 minus rho 1 into GH2. That rho 2 minus rho 1 is given in the bracket and GH2 will come outside. Okay, because rho 1 is equal to rho 3. So first time and last time will cut. So we will get the balance as rho 2 minus rho 1 into GH2. Okay, this is the final equation for finding out the difference of pressure between two liquids flowing through two pipes at the same level.